So I got a haircut and it is awful. So it'll grow out. Time for some coffee. That makes everything better. All right, ready? Let's do it. Every 10 minutes, somewhere in the world, a computer solves a really hard puzzle and as a result is rewarded with over 350,000 US dollars worth of Bitcoin. That's every 10 minutes, which adds up to over $2.1 million every hour. But this isn't some slot machine in an internet casino. It's the backbone of the entire Bitcoin network. Today, we're breaking down how Bitcoin mining works, including 5 key topics I'm going to cover. 1, the cryptographic puzzle the miners are actually solving. 2, the step-by-step mining process. 3, how mining differs from running a node. 4, the economics that make it profitable for miners to do this, and what modern mining actually looks like today. By the end, you'll understand why Bitcoin mining is one of the most ingenious economic systems ever created. And you'll be able to explain it to your buddies at the next barbecue. If that sounds good, let's get to it. The Bitcoin mining puzzle. So what exactly is this puzzle that's worth so much money, or Bitcoin? Let's start with the fundamentals. At its core, Bitcoin mining is all about solving a special kind of puzzle called a cryptographic hash. But here's what miners are actually doing. Imagine you have a magic box that takes any data input and magically creates a completely random-looking 64-character string. This is called a hash function, specifically SHA-256 hash. For example, if you input the word hello, you're going to hash a 64-character string, and it's going to be a certain setup. Every time you input the word hello, you get the same hash. When you input the word hello with an asterisk after it, you get a completely different hash string. But every time you put hello with an asterisk, you get the exact same string. So it's deterministic. That is, the same input always creates the same output. And changing even a single character of the input changes the output entirely. And you guessed it, you can try this at home. On a Mac, you need to open your terminal application and type in echo, and then the input, let's just say hello, and you put that in quotes, then a vertical line, then the word shasum, I'm going to show you this in a second as well, then a flag A, then 256. I'll put the Mac prompt and the Windows command prompt in the description below. Let's go ahead to the terminal, and I'll show you this in action. Okay, here we are at my terminal application on my Mac, and I'm going to go ahead and paste that command in, and we're going to go through it real quick. So we have the word echo, space, quotation marks, and then the input you want to get it, the hash of, and then quotation marks, and then the rest of the command, shasum, with the A flag, and then 256. In order to get some interesting numbers, let's try Bitcoin. Whoops, there we go. Don't want to put 2 quotes, and I'm going to press enter, and we should get this long string. There it is. Now let's do that same command, and I'm going to change one letter. I'm going to add an asterisk and see what happens if the hash changes a little or if the hash changes a lot. And it changes a lot. Wow, that's a completely different number from a single character difference, okay? That is the hash. And you'll see this used a lot in GitHub to validate downloads, that making sure that you're creating the same hash with the download as the author or the coder did as well, to verify the download is accurate. Oh, one last thing. I wanted to make sure that I gave you the command for Windows. This does not work on the Mac, but it's very similar. Echo, and then the word you would like to hash, certutil, hashfile, SHA-256, okay? That is the command you can type into the Windows command line and get the hash of your input. Back to the video. Now, here's the puzzle. Miners need to find an input that produces a hash starting with a certain number of zeros. Currently, Bitcoin requires approximately 19 leading zeros. That is, that hash number, the 64-digit number, has to start with 19 zeros. And the only way to figure this out is trial and error. So you put in 0, and if it comes up with 19 zeros, you win. If it comes up with 3 zeros, you put in 2 or 1, and then you put in 2, and then you put in 3, and 4, 5, 6, etc. And you keep trying combinations of inputs to achieve this hash that you need to solve the puzzle and get the block reward, sort of win the block. In other words, confirm the transactions in the block. This system is called proof of work because miners have to prove they did the computational work to find a valid solution. You get it? Proof of work. But the miners aren't just hashing all random data. They're hashing a block which contains a link to the previous block, which is the previous block's hash number. It also contains what's called a Merkle root, which is a summary of all the transactions in the block. It contains a timestamp for when the block was created. It contains a difficulty target, in other words, how many zeros are required. And the miners are also hashing what's called a nonce, N-O-N-C-E, which is the magic number they're trying to find, or use, I guess, to create the hash, which starts with 19 zeros. So the nonce is their attempt. All the other data is sort of realistic data, and then the nonce is what they make up each time they try. So they try these nonce values starting at 0, 1, 2, 3, hashing the entire block each time till they find a nonce that produces the winning hash with the appropriate number of zeros. So how hard is this process? The current Bitcoin network processes around 800 to 900 exahashes per second. That's roughly 800 quintillion hash attempts every second globally. To put this into perspective, this represents millions of mining computers working together across the entire planet, which is an incredible feat of distributed computing. Now that you understand what miners are actually trying to solve, let's walk through exactly how they go about doing it step by step. Step 1, transaction collection. The entire mining process starts with collecting transactions for the block. Miners monitor the Bitcoin mempool, which is the waiting area, or the bucket, if you will, or pool of unconfirmed Bitcoin transactions. Then they select which transactions they'd like to include in the block. And you guessed it, if the transaction has a higher fee, that one gets picked. Each block can hold somewhere between 2,000 and 4,000 transactions, depending on their size, of course. Next, miners build their candidate block. First, they create a Coinbase transaction. Yes, it's an actual thing. I was shocked. Which pays themselves the mining reward, which is currently 3.125 Bitcoin per block. A Coinbase transaction is a special transaction that creates Bitcoin out of thin air. I'd like to have a few of those. With no inputs. And it becomes the very first transaction in every block, allowing the miners to reward themselves for their work. Then they arrange all the transactions in a specific order, and they calculate the Merkle root, which is a summary of all the transactions in the block. Then they add the previous block's hash, creating the blockchain link. Each block has the hash in it of the previous block, so it's linked and linked and linked. And for step 3, now the real competition begins. It's the hash race. Miners start with nonce 0 and hash the entire block to see if they get the winning number. If the hash doesn't have enough leading zeros, then they move to the next increment and hash the whole block again. This continues with 2, 3, 4, etc., potentially billions of times per block. A modern ASIC mining computer can try somewhere between 2 and 500 trillion hash combinations per second. Yeah, you can't do that at home. And step 4 of the mining process is when a miner finds the winning hash. Then they immediately broadcast their block to the network. Other miners and nodes verify that their solution is correct. And if it's valid, everyone adds that block to their copy of the Bitcoin blockchain. The winning miner receives 3.125 Bitcoin, plus all the transaction fees in the block, and everybody starts working on the next block. And step 5 is the difficulty adjustment. Every 2016 blocks, roughly every 2 weeks, Bitcoin automatically adjusts its difficulty. If blocks have been found too quickly, the difficulty increases, which means more zeros would be required. If blocks were found too slowly, given the 10 minutes per block goal, then the difficulty would be reduced slightly. This keeps the average block time approximately 10 minutes, regardless of how many miners join the network or leave the network. And this process repeats approximately every 10 minutes across the Bitcoin network. Here's where many people get confused. They think mining and running a Bitcoin node are the same thing, and they should be getting paid to run a node. They're actually totally different. While they are related a little bit, they serve completely different purposes. Let me break it down as clearly as I can. A Bitcoin node is like a vigilant accountant. A node stores the complete blockchain history, approximately 600 to 700 gigabytes now. They validate every transaction according to Bitcoin's rules. They relay valid blocks and transactions to the other nodes on the network. They enforce consensus by rejecting invalid blocks or transactions, and provide blockchain data to wallets and applications, like the Sparrow wallet. Running a node costs maybe $200 to $500 of equipment and essentially no electrical costs. But there is no direct financial reward. You do it to verify your own transactions, improve your privacy, and support the Bitcoin network. You get the warm, fuzzy feeling. Whereas mining is like being a competitive chess master and an accountant at the same time. Miners compete to solve the cryptographic puzzle first. The miners create the new blocks and add them to the blockchain. Miners earn rewards for creating successful blocks, and miners require very specialized, very expensive ASICs hardware, costing thousands of dollars per unit. And miner facilities consume massive amounts of electricity. Every miner runs a node, but most nodes don't mine. But here's how they work together. Nodes maintain the official state of Bitcoin and relay transactions to the miners. Miners collect the transactions and then compete to win the block. When a miner finds the hash solution, they broadcast it to the nodes. Nodes then verify if the block follows the rules before they accept it. Nodes then relay the verified block to other nodes and the miners. Think of the nodes as the judges or referees, and then the miners as the competitors, basically. The miners cannot succeed without the nodes verifying and accepting their work. And the nodes depend on the miners to create the new blocks. And Bitcoin's exceptional security comes from this separation. Nodes prevent invalid transactions and maintain consensus. And the miners make the network nearly impossible to attack through computational work. Together, they create a system where changing the past requires tremendous cost, while following the rules is rewarded and profitable. Speaking of profitable, if mining requires all this expensive equipment and a ton of electricity, what makes it profitable? Bitcoin's genius is in its economic configuration. Every 210,000 blocks, or approximately every 4 years, the block rewards get cut in half through a process called the halving. In 2009, the block rewards were set at 50 Bitcoin per block. That would have been great. Currently, like I mentioned, it's 3.125 per block as of May 2024, or was it April? I think it was May. And it's going to get cut in half again to 1.5625 Bitcoin per block in 2028, approximately. Eventually, the block rewards go to zero, which creates Bitcoin's 21 million Bitcoin limit. As block rewards decrease over time, the transaction fees become more and more important. Users pay fees to have a transaction included in a block, and the miners prioritize those transactions with higher fees. Make sense? During really busy periods, those fees can even exceed the block rewards. This assures that miners can remain profitable even when the block rewards end. This mining profitability drives the miners in a constant technology race. More efficient chips that the miners use to hash blocks means more profit, and profitable mining attracts more miners. More miners increase difficulty. Higher difficulty requires better equipment, and around we go. This chip arms race, or Bitcoin technology arms race, creates several effects. One, energy consumption. Right now, the Bitcoin network uses between 160 and 175 terawatt hours per year, which is more energy consumption than Finland, Switzerland, and Denmark combined, or comparable to the energy consumption of countries like Poland, Egypt, and Malaysia individually. It also creates geographic distribution of the network because miners are incentivized to move to areas with cheaper electricity. And it also pushes technological innovation. This chip arms race drives technological innovation at the chip manufacturing companies incredibly. And it also creates economic security in the Bitcoin network. Basically, it makes attacking the Bitcoin network prohibitively expensive. Attacking the Bitcoin network would require controlling 51% of the mining power, which is insanely expensive. At current prices, this would cost billions of dollars in hardware, plus massive ongoing electrical costs. Meanwhile, honest mining is very profitable. This makes cooperation much more profitable than attacking. These economic forces have shaped how Bitcoin mining operates today, which looks very different from the early days of the network. Today's mining is dominated by massive mining operations. ASIC miners have specialized chips designed only for Bitcoin mining. Miners have set up mining farms around the globe, which are warehouses containing thousands of these ASIC mining machines. And each individual mining unit uses about 3,000 watts of electricity. So these mining warehouses have to have industrial cooling systems, or some have actually used liquid cooling and put the ASIC miners in liquid. And a lot of these Bitcoin mining companies have negotiated contracts with electric companies and ASIC mining companies for bulk discounts. Most miners join pools of miners to reduce variance. In other words, individual miners might wait years or never find an actual block on their own. Pools, however, combine everyone's hash rate that joins the pool and shares the rewards proportionally. Contribute more hash rate, you get more % of the rewards, which can provide some miners with a steady, predictable income. And the pool operators take 1 to 3% of fees for operations. And the largest pools control 20 to 30% of the network hash rate each. They're big. So, can you mine Bitcoin profitably at home? Not really. Residential electrical rates are typically too high to make a significant profit. Modern ASIC machines are extremely loud and generate a ridiculous amount of heat. And competition from industrial scale mining makes small scale mining basically unprofitable. Devices like BitAxe are really fun to have, but they're more for education and lottery style participation more than profit. The days of profitable garage mining ended in 2012, 2013, when the ASIC mining computers were introduced. Bitcoin mining's energy use is often criticized, but consider these facts. Many operations use renewable energy like hydroelectric or solar, currently estimated at around 40 to 50%, but this rate is expected to reach approximately 70% by 2030. Miners are looking for the cheapest electricity, often it's surplus renewable power. And miners can provide electrical grid stability by consuming excess electricity, as we found out in the state of Texas. And this energy secures a global financial network serving millions of people. When you step back and look at the entire system, what we've just walked through represents something absolutely amazing in the history of technology and economics. In conclusion, Bitcoin mining is far more than just digital gold digging. It's an elegant solution to one of computer science's hardest problems: how to achieve consensus in a distributed network without a central authority. So here are the key takeaways. Mining secures the Bitcoin network through a computational proof-of-work system. Miners compete to solve puzzles and earn rewards for doing so. Nodes validate transactions and maintain the consensus of the network. And economic incentives align individual profit with network security. And the whole system adjusts itself every 2 weeks to maintain 10-minute block times regardless of changes in mining power. What makes Bitcoin mining so brilliant isn't just the cryptography, it's the economic game theory. Satoshi created a system where being honest and following the rules is more profitable than trying to attack it. That's the real innovation that makes Bitcoin work. So what aspects of Bitcoin mining surprised you the most? The computational scale, the economic incentives? Go ahead and leave me a note in the comments. Smash the like button. Don't forget to subscribe while you're down there. After all, it's free. And thank you so much for watching. I really appreciate it. Stay sovereign, stay safe. I'll see you in the next video.